Hi everyone. So let's go over how to conduct a paired samples t-test in SPSS. And as you know, or at least you should know, that for paired samples, it's when you are comparing the same group twice. So they would take, for example, they would conduct a test one time and you would get their scores, and then they would perform the test again a second time, and then so you would compare the first and the second time, and so your group is essentially the same person you're testing twice. It can also be thought of as like repeated measures or within groups. So in SPSS we call that paired samples t-test, and for t-tests you essentially have two groups, which is considered a categorical variable. For us, our two groups is the first time they took the test, and then the second group is the second time the individual took the test. And for our data, we are conducting the Stroop test, the Stroop effect, and that's where individuals are being timed on how long it takes them to read a word that is in a certain colored font. And if the word green, for example, matches the color of font green, you would say that the word and the color matches, and you see how fast it takes individuals to read a set of words where the color and the word spelling matches. The Stroop effect is when they are mismatched. So instead of green being in green font, green would be in, for example, red font. And so it's harder not to read the word, but to say the color of the word. So your brain automatically wants to process reading, because it becomes an automatic process after we've learned it. So it's harder to ignore that automatic process and then say the color of the word instead. And then our dependent variable is time, because we're measuring how long it takes a person to read the set of words when the color and the spelling matches, compared to how long it takes an individual just to say the color of the font instead of reading the mismatched spelling of the word. So continuing on, let's actually conduct the paired samples t-test in SPSS. And you can see for our data we have time 1 and time 2, and you can kind of tell that those are times. If we look in the variable view, you can see we've labeled it where the word and the color are consistent, and then for time 2 the word and the color of the word are not consistent, they're inconsistent. And you can see SPSS calls continuous data scale data. So let's go ahead and perform our analysis. You can run the analysis whether you are in variable view or data view, it makes no difference. So click on Analyze, Compare Means, Paired Samples t-test. And this box should show up, and you can see it put in the nice labels that we've put in here. And what you do is you grab the first one and you slide it over into variable 1, and you grab the second one and slide it over into variable 2. SPSS has already given us the option to run more than one test automatically, but we only want to run one test comparing our two variables, so we ignore the new column that it's produced, and then just click OK. And it's as simple as that. Now you can see the results of our t-test here. So moving on to calculating the effect size. So in SPSS, for some reason, when you perform a paired samples t-test, it does not provide the effect size for paired samples t-tests. And to obtain that, you would divide the mean difference by the standard deviation of the difference in scores. And for convenience, I have copied and pasted our results into this PowerPoint. And as you can see, we have mean and standard deviation up here, and we also have it down here. The difference here is the mean for this row is just the mean for this variable. It's the average time people took to read the words and the colors when they matched. And this is the standard deviation for that variable. And the same with one below. Here is this mean down below is the mean difference between these two scores. So if I were to take this mean and subtract it by this mean, I would end up with this mean down here. And the same with standard deviation. When I subtract them, I would end up with this score down here. Okay, so to calculate the effect size, once we calculate the effect size, I should say, of our results that we obtained when we performed our test, we would end up with 1.24. Well, we know that for Cohen's d, a small effect size is 0 to 0.3, and a moderate is 0.3 to 0.6, and a large effect size is 0.6 and larger. But how did we end up with an effect size that is 1.24? And just to review, when we are typically students are just looking for a significance test to see if there is a significant difference. But also important is to calculate effect size, because that will inform us about how strong that test was. How strong was the difference? So if we get a significant difference, which we can see we did in this test because it's 0.05 or less, and for us it's very much significantly less, 0.000, we want to see how strong is that relationship. Just because it's a very low number here, it doesn't necessarily mean the effect size is very strong. But since we ended up with 1.24, which is much larger than even 0.6, we know that we have a very strong test here. And in fact, this score that is above 1 just means that the two means is larger than one standard deviation. If it was 2 or larger, that means it would be 2 standard deviations. So that's why that score is so much higher. Okay, so now to be able to write the results of these outcomes into an APA format paper, this is how you would do it. So here again are our results. And to write this into an APA format paper, I would suggest writing exactly this sentence that I have up here on this PowerPoint, which says, a paired samples t-test indicated that scores were significantly higher for words with consistent spelling and color. And here is the mean and standard deviation for the consistent word and color up here. You can see 27.35, which is actually rounded up to 27.4, and same with standard deviation. Then for words with consistent spelling, or I should have put inconsistent spelling and color. And you can see that the mean is the same as you see here. And then here is the T. This represents the t-test. And then we have a funny little number right here. And what that number represents is the degrees of freedom, which you would see right here, DF, in our results. And degrees of freedom, if you recall, is n minus 1. See, our n is 41. So if it's the degrees of freedom is 41 minus 1, which is 40. and then you put in your t statistic, which I didn't do. For our results, the t statistic is right here, and so you go ahead and put that in. 7 point, oh, that's really high, so it's actually 8. Well, let's go ahead and put 2 decimal points. 7.97. There we go. And then our p-value or significance test is actually less than 0.001, as you can see down here. And here is what we calculated by calculating Cohen's d at 1.24. If we go back, here you can see 1.24. And so that's how you perform a paired samples t-test. Calculate Cohen's d, the effect size, and write the results for the paired samples t-test in APA format. All right, thanks guys.